Hello everyone, let's talk about another medium problem today. Remove duplicates from the sorted list 2. Uh, Leetcode 82. I think we have already seen remove duplicates from sorted list 1. And this problem is medium because it also involves some more edge cases compared to the previous solution or previous problem. So it says that given the head of the sorted linked list, delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. So it says that we have a linked list here, one like which has some elements in it, and in the end, wherever we see duplicates, for example, 1 and 2 are not duplicates, but 3, 4 are duplicates, right? So you will not see it in the new list or the current list. We just remove it in place. And we also keep the number 5. Similarly, here 1 is duplicate, but rest of the 2 elements like 2 and 3 are not. So we will keep that into the list. So let's think about this problem a bit. Like we have seen similar problems, right? So what we could have done is like we need something like a two-pointer approach where we just need to compare the 2 pointers left and right, where right is actually increasing the boundary and left is the place where there is no duplicate inside the list. But the problem will be maybe the 1 is also duplicate, right? Like we have seen here. So then where should we keep the left pointer in this case? The hint is like we should keep it before the left pointer, and this is where I will say dummy pointers come in. We will explore this concept in a minute. Another solution is like we can also use a hash map or hash set, like whenever we see the element and we just maintain the hash set till the end of the list, and whichever element occurred only once, we just keep that in the list, right? So for example, we start with 1, add 1 to the list. I'm talking about this example. Now we go to 2, and this time we see that okay, 2 is not yet in the list, but 1 is now complete. So that means 1 will be part of the output. Then we go to then similarly 2 will be part of the output. Now 3 comes in, right? 3 will be added to the set. And then we go to the next element, which is again 3. So that means 3 is actually a duplicate. So we will ignore all the 3's now, and don't add it to the set. Similarly, we will do the similar logic for 4 and 5. So basically, as soon as we find out there are duplicates, we just skip the nodes completely. But because the list is sorted, using 2 pointer will give us O of will take only O of 1 space, while when it comes to hash map or hash set solution, I think it will use O of n space, because all the elements may be duplicates, for example, right? And or like all the elements may be unique. Sorry, in that case, I think when all the elements will be unique, you will be storing them in the set. Yeah, now let's jump into the dry run and let's look at this example now. So in this case, we can see we have a linked list 1, 2, 2, 3, 3, 3, 3. So it's like the output should only be 1. But if you realize that like there may be a case that, for example, even the 1 may be duplicate, right? So if we use a two-pointer approach, we may have to handle the scenarios like this. And when we have to deal with a case where even the first node can be problem, it's a good idea to use a dummy pointer or dummy node. So what we will do is like first thing we will do is like create a dummy node, and this is a dummy node, right? We can just point it to any value like 0, -1, or whatever you prefer, and this will be our dummy pointer. And we will point like head will stay at the same location. And now what we need is like 2 pointers left and right, and as we saw in the previous problem also, we don't need 2 left and right pointers. We just need current, and current will be the point where there are no duplicates, and current dot next or next or whatever is the span will be moving towards the right, marching and finding the right, finding all the duplicates and getting rid of them. So let's see how we can do this. So initially we have this current pointing to the dummy node, and current dot next pointing to the head. Then what we will do is like we will check if current dot next dot well, so in this case 1 is equal to 2. If yes, that means those are like duplicates, so we have to get rid of them. And what we will do in this case is, in this case, the answer is no. So we will just move the current. So now in the iteration 2, we can see that current is now pointing to 1. Current.next is basically 2. Current.next.next is also 2. So now we check again. Is current.next.well is equal to current.next.next.well? And the answer is yes in this case. So that means we have to do the cleanup. So the beauty of this is like current is pointing to the point where there are no duplicates. So, okay, dummy is our node. We don't care about it. But one we do care about, right? That should be part of the answer. Uh, so now what we will do is like as long as we find this 2, we will just go through the list, say in a while loop or anything, and just do current.next.next.next, right? What we will be doing is like current.next is equal to current.next.next, right? Until we find the point where there is no duplicate, right? Now after this iteration, we will find 3, which is not equal to 2. So now our list is again clean, but note that we didn't move the current at all. Current is still pointing at 1 because this is the point where there is no duplicate in the list. Now we again point current, and how do we know? Because the list is sorted, right? That's the main thing. Otherwise we couldn't have done that. And now we see, okay, current.next is 3 and current.next.next is also 3. So again, yeah, those pointers, we will go to the end of the list, and there will be no other point remaining. So we will come out of the loop, and what we will output is not dummy, but or current. Actually, we will be outputting dummy.next. And please forgive me for this typo. Current should not have been here. So yes, this is the current solution, and in the end we just return 1 in this case. Now let's jump into the code part. Yes, so first thing we will do is we will create a dummy pointer like we talked about, right? So sorry, I'm just thinking like a array list in Java or something. Dummy is equal to 0 minus 1, whatever you take, doesn't matter. Main thing matters is we just point dummy to the current head, right? And also we will point current to dummy, because we don't like, this is the advantage of dummy, because we don't have to worry about null pointers or anything. We know that dummy actually exists. And now we will just again do the same thing, have current.next or in current.next.next as a way of a right pointer, and the current will be our left pointer. So not equal to null, and current.next.next not equal to null. We need it because we want to compare current.next.well and current.next.next.well, right? So we know this because they exist, because there's no what you say, we have already checked it in the while loop condition above, so we will not get the null pointer exception here. So we know that if it's equal, we can say that, okay, that value is current dot next dot well. And now we will run the while loop just till the point where we have this value equal to duplicate. We will just do current dot next is equal to current dot next dot next. So that means skipping the nodes. So now what we will do is just we will, yeah, just set. And because we are always checking on current.next not equal to null, so it will also take care of the case if we reach the end of the list. Otherwise what we will do is like if the values are not equal, we will just say current is equal to current.next. We just move the current pointer, And because we didn't change anything from dummy dot next, it should always be our head, regardless of the scenario, whether value in head is duplicate or not. It would have been taken care of based on the loop above. uh, so we will just return dummy dot next, and that's it. Let's test it out. We got the null pointer exception, the exception we were trying to avoid. But let's see, where do we get it? So it says you got the null pointer exception on line number 17. Field next cannot be null. And then it says that, okay, so let's see why this may have occurred. So we are checking current dot next not equal to null. Because I'm using single and ampersand instead of double one. Uh, so I think that may have caused the issue and wouldn't have been properly handled. Awesome. So I think, yes, this solution beats 100%. Of course, it doesn't matter anything because so many people are submitting the code, and it just gives some, I feel it gives kind of a correct answer, but sometimes it varies. Main thing, what matters is like the time complexity is O of n, because we are pointing to or processing each element only once, right, in the list, and we are not using any extra space or anything. And this is the best we can do in the current constraints that we are given. I hope you like the solution. Please like and subscribe the channel. It helps a lot. Thanks again and have a nice day.